In this video, I want to address an interesting topic about wood stoves, and that is the question of outside air and an outside air connection. Now, I say outside air, what do I mean? Well, wood stoves consume air for the fire, right? Oxygen is what takes part in that combustion reaction. On this Woodstock soapstone ideal steel, the air control is right here on the front of the stove, and the intake is underneath on this side. So if we take a look under this side of the stove, we see that there's some interesting shaped openings, and that's where the air is allowed to go into the stove for combustion. Now, the way that the default stove is configured, it's going to draw air directly into it from the room in which it is sitting, which is inside the house. So it's consuming air from inside the house. If you have an outside air adapter kit, what happens with this stove is there is a steel kind of box or cover that goes over those air inlets and connects to a duct, which would then run to the outside of the house, so that instead of drawing air from the room in which it sits, the stove would then be consuming air from outside the house for the fire. So now let's take some time and just explore that question of whether or not an outside air connection is necessary. Now, in some municipalities, an outside air connection for a wood stove is going to be required by law or by code. And if that's the case, regardless of anything else that I share in this video, you need an outside air connection. But for those of us where it's not required by law, it actually could be a somewhat serious consideration of whether or not to get that connection, because it certainly will add additional cost to the stove and additional installation considerations. So is it something that we should do? Well, let's think about combustion. As I mentioned, the stove is drawing in air from the room in which it sits, the fire burns, and then the off gas or smoke from the fire travels up the chimney. In other words, there is a stream of air flow into the stove and up the chimney, and that air is coming from inside the house. Now, if your house isn't very tight or a little bit drafty, this is no big deal because the air from outside will infiltrate into the house, which will then make its way to the stove and then up and out the chimney. And you'll have this kind of air circulation going on, and the air should flow pretty readily. The chimney should draft pretty readily. Where we start to get into issues is in modern houses that are very tight and very well insulated. Now, all of a sudden, it's harder for air to infiltrate into that house and establish a consistent flow of air into the stove and up through the chimney, because you have to have that infiltration coming in order to establish that flow through the stove and up the chimney. What can sometimes happen in these situations is it can be difficult to establish chimney draft. And what that means is it can be hard to get the smoke going up the chimney and get that airflow going, because you're trying to fight against essentially the atmosphere and the pressures that exist between inside and outside the house, and you don't have that ability to get good airflow. As a result, you can get a back puff, you can have some smoke kind of billow out the stove into the house instead of making its way up the chimney the way that it should. The solution to this that is out there is an outside air connection. And like I explained, that's where you put a duct of air directly to the intake on the stove so that it's pulling air from outside. Now, what this does is it bypasses the air in the house so that there's a free supply of air into the stove, which can then be exhausted up the chimney regardless of how much air can infiltrate into the house. Theoretically, that would solve a lot of those draft problems and that tendency to back puff and those issues. But does it really? And that becomes the big question. And for that, we need to dive into a little bit of science and a little bit of fluid mechanics, because air is actually a fluid. We're going to first consider the Bernoulli equation. Now, what the Bernoulli equation says is that the pressure in the fluid divided by its unit weight plus the velocity of the fluid squared divided by 2 times the acceleration due to gravity plus the elevation is equal to a constant, which we will call h. So that is the Bernoulli equation. With h being constant, if you change pressure or velocity or elevation, you're going to see changes in the others, right? So if you increase the velocity, you have to decrease the pressure or the elevation to maintain a constant h. And this is where things get interesting. Now, I am simplifying things. I am coming from the standpoint of incompressible flow, which is not entirely true in this situation, but it at least helps make a simplified explanation. So let's take this to the context of our house, right? We have an indoor environment where we've got pressure, velocity in the air, and elevation. And then we have an outdoor environment where, again, we have pressure, velocity in the air, and elevation. Now, for the sake of simplifying our argument, let's say that the elevation is the same inside the house and outside the house. On top of that, we could also make the assumption that the velocity of the air inside the house is approximately 0. Because when we're comparing to what happens outside with wind and everything that's going on in the atmosphere, our inside air is relatively stationary. With that kind of assumption in place, what we start to be able to do is look at what's happening with this equation and what's going to be required for air to flow in a particular direction. So now that we understand this Bernoulli equation and that we have a constant value of h, what happens is in order for airflow to occur, there needs to be a difference in the value of h between 2 points. In other words, if the value of h inside is different than the value outside, airflow will occur. And it will occur from the higher value of h to the lower value of h. So at the end of the day, what this really is all going to come down to is pressure, and whether or not the pressure inside the house is greater than the pressure outside the house. If that's the case, then air will flow out of the house, and it doesn't matter whether or not there's infiltration from outside, because if the pressure's higher inside, the air is going to flow out any way it can, including through the stove and up the chimney. So that's not an issue. Where things become an issue is when the pressure inside the house is less than the pressure outside the house. Now, this could be caused by a number of factors, but the big one that's common in a lot of our homes today are going to be our exhaust fans. So that could be an exhaust fan over a kitchen range. It can be our bathroom exhaust fans. It can sometimes even be the air exchange system for the house. If it's sucking air out of the house, it's going to induce pressure that's less than the atmospheric pressure in the house. And of course, that means that if air is being drawn out of the house, air needs to come in. And it's got to come in from somewhere. And that's the problem with our tight houses. The biggest hole might actually be the chimney coming back through the air inlet on the wood stove. And that can lead to some of those down puffs. The outside air, in theory, alleviates this issue. But there's still a catch. And the catch is what's happening outside. So if the air is all still outside, nothing is changing that value of h. We kind of bring the outside equilibrium through the stove and separate things from what's inside, and all would be fine. The problem is the outside conditions change all the time with the weather. You have different atmospheric pressure on different days. You can have high winds or low winds. Let's just take wind for an example. Let's say wind is blowing across our house, and we're going to have one side of the house that is sheltered. And if the air inlet for the stove is on that sheltered side of the house, this is the important factor to consider. The high velocity air from the wind is moving over the top of the house, but in that sheltered area, the velocity is near 0. Well, what that means is the pressure, because h must be constant, the pressure is going to be higher in that sheltered zone than it is in the high velocity zone. This is the same principle that applies to the way airplanes fly. And so the air from that sheltered zone by that air inlet on the house is going to move up and away from the house toward the lower pressure, fast moving air. Well, now your inlet to your stove might actually be acting like a straw where the air could flow in the reverse direction that you anticipate. Now, I'm not saying that this is likely to occur, but it is absolutely a possibility once you have that opening there connected directly to the chimney. Obviously, if that happened, it would be a significant problem. If the air, on the other hand, were blowing the other way, it would be no big deal because the wind would just push harder into that air inlet and essentially force draft your stove, and your stove would probably burn a little bit faster, or you'd have to reduce the air setting a little bit in order to moderate that burn rate. So one way the wind blowing could be an issue. Another way might be less of an issue. If you don't have that air connection to the outside, your house would actually moderate that effect. So if your stove is drawing air from inside the home, if you've got infiltration coming from inside the home, it's going to come from everywhere. You're not going to have a low pressure zone inside of your house per se that's trying to suck air away from your wood stove. In that sense, not having that outside air connection lets your house moderate that air infiltration and takes away that potential problem. Where does this leave us? Should you get an outside air connection? The answer is maybe. Maybe it will help alleviate issues with draft and things of that nature in your house if it is tight. However, if you have an older home that's not super tight and you get some natural air infiltration, arguably that outside air connection is not the way to go. Obviously, I don't have an outside air connection to either of my stoves. Sometimes I have both of them burning at the same time with no ill effects, and my chimney drafts very well. And that is because air is able to infiltrate into this house at a rate that is equal to or exceeds the rate that is needed to flow into these stoves and up the chimney with good draft. That being said, we still have had outside environmental conditions that have caused little minor downdrafts and down puffs of smoke through these stoves. So nothing is going to make your house necessarily completely free of potential back puffs or draft issues. There's a lot going on with how stoves operate, and so it's just important to be aware of that. So keep this in mind if you're thinking about buying an outside air kit. It could help your stove installation, or it might not change things much at all. What's really important though is to establish good draft with your stove when you first start a fire. And sometimes doing that, if you crack a door or crack a window, it can really help get things going as you're starting to heat up that air in the chimney and get flow going up and out of the chimney rather than spilling out of the stove and into the house. Hopefully you found this video informative and helpful. And if you do select wood heat for your home, I hope that you find it to be an enjoyable process and an enjoyable source of heat.